So this is so fast. As you can see, it just took 1 second or 2 seconds to generate the response. $1 trillion loss in the US market. This is a big deal. DeepSeek R1 is all over the places. It deserves the hype for multiple reasons. DeepSeek R1 is on par with OpenAI O1 in performance, where you need to pay $200 to use OpenAI O1. DeepSeek is free and open source. DeepSeek API pricing is 27x cheaper compared to ChatGPT APIs. This proves that having domain knowledge in algorithm complexity is very important. Just now, we also got the benchmarking on RKGI. If you don't know what RKGI is a very critical benchmarking which evaluates the LLM based on their thinking capabilities and visual based answers, where OpenAI O1 achieves 18% on semi-private evals and 21% on public evals, whereas DeepSeek R1 achieves 15.8% on semi-private evals and 20.5% on public evals. This benchmarking is not a very easy thing to achieve, and DeepSeek has done a very good job in order to achieve it. From my experience till now, DeepSeek R1 is really good when it comes to coding related tasks and reasoning based capabilities. But when it comes to general knowledge based fact, DeepSeek is not that great compared to GPT as of now. But again, we are in the space of AI where models are built every single day. It's time to start today's video where we will build a RAG pipeline that can index 1000 plus pages of document using Qdrant Binary Quantization for quick indexing and memory efficiency. And we will also use DeepSeek R1 as our LLM model from Groq for faster responses. This is going to be a project based video where we will build Bhagavad Gita Assistant. This project is one of my favorite, and let's have fun building it. Let's understand the architecture diagram in order to build Bhagavad Gita Assistant. The first step is we need to have the document. I've already downloaded the PDF that is required to build the knowledge base. You can find the link of the PDF in the description so that you can download it and use it in your application. The next step is you need to convert the data into vector embeddings. And in order to do that, we will be using FastEmbed that is also provided by Qdrant. And once you convert your data into embedding format, this is where you need to save that embedding in a vector database. This is where we will be using Qdrant again with binary quantization. And how do you define this binary quantization? It is very simple. Let me break down the steps. In order to define the vector database, the first step is you need to have Qdrant client. Qdrant client, you need to define the location where the vector database will be hosted. This can be achieved in 3 different ways. The first way is you can create a cluster on Qdrant Cloud where you can get the API keys and as well as the hosted URL. The second approach is you can download Qdrant locally, where you just have to pull the Docker image and you have to use localhost. The third approach is you can use in-memory. And up next, we have vector configuration. In vector configuration, you usually define the embedding size of your vector, which varies between 512, 756, 1024. And apart from vector embedding size, you also define the distance. In our case, it will be cosine similarity. And lastly, you have quantization configuration. This is where you need to define models from Qdrant, and under models, you have binary quantization. And when you define the models, we just have to make sure that always RAM is equals to true. So let's proceed with the next step. So once you have your embedding saved in the vector DB, you are good to go with the user query. Now what we will do is we will bring the user. So this user will ask any query that is within the document, and in order to run this particular query, again you have to convert that into query embeddings. So for query embeddings, you can use a function from fast embedding itself so that you can get the embeddings of your input query, and then you have to use something called as query points. So query points is also provided by Qdrant itself, where you need to pass the query, which is your embedding, and the vector DB. Vector DB is nothing but the collection name that you provide, and based on that you can define what is the K. How many relevant documents do you need? Whether you need 5 relevant documents, 10 relevant documents, 15 relevant documents, you can define the limit of it. So limit is the parameter name, And once you have these query points, you can get the context. Once you have the query points, you will get the context out of your vector database. Now you just have to write a prompt. So this is a typical RAG prompt where you have to give the user query and the context, where you have to tell, hey, this is the context and this is the user query, give me the response. And if the user query is not from the context, just tell I don't know. Simple. And once you add this particular prompt, pass it to the LLM. So LLM is where we will use DeepSeek R1, which will do the reasoning capability using the Groq. So in Groq, usually you will be using the digital model. And once you have this LLM ready, you have the final response. This is what we will be building, and it's very simple to build it. So let's start with code implementation. Alright, it's time to start with code implementation. We will divide the code implementation into two parts. The first part is we will convert our data into vector embeddings and then save it in a vector DB. So this is what you call as indexing methodology, where you are creating a knowledge base. The second part of the code is once the knowledge base is created, you just have to use the collection name and then build a RAG pipeline. So this is the second part of the code where you are using the created knowledge base. And in order to create the knowledge base where you can save your data into vector store, we will be using GPU from Colab. And in order to use Colab GPUs, you have to click on runtime, then click on change runtime type, and then select T4 GPU. So this is where you will be getting 15 GB of VRAM so that you can utilize the GPUs to convert your data into vector embeddings and then saving in a vector DB. So let's click on T4 GPU and click on save. And once you do that, if you look at this particular tab, you can see T4, that is, it's already connected with a GPU access. So you are just converting the hardware accelerator from CPU to GPU, that is T4 GPU. And the next step is you have to click on this directory icon, create a new folder. So the folder name can be data, and inside this data we need to click on upload. So I'll just right click on upload, and then I will upload Bhagavad Gita document. So as you can see, the Bhagavad Gita document is already uploaded. So now let's proceed with the installation of the packages. We will be using LlamaIndex to create the RAG pipeline. And in order to use the vector store, we will be using Qdrant. And the next step is, in order to convert the data into embedding format, we will use FastEmbed, which is provided by Qdrant embeddings itself. And then in order to read the data, so now we have PDF, right? How are you loading the data? This is where we'll be using LlamaIndex readers file. And lastly, in order to generate the LLM based responses where it can think and generate the response, this is where we will be using Groq. And from Groq, we will use the LLM model called DeepSeek R1. In order to understand what the model name needs to be provided, you have to click on Groq documentation. Here you have a section called models, and inside models, you have something called as preview models. And inside preview models, you have DeepSeek R1 distill Llama 70 billion parameter model. We will use this particular model to create the inference of your RAG pipeline. So now let's get back to the code. And once the installation step is done, we will start with basic import statements. So I'll ignore this part. These are very simple import statements. And we'll start from here. The first step is you need to import Qdrant client. So as you can see, import Qdrant client, so that if you remember this diagram, in order to create this particular vector store, you need to have Qdrant client where you are providing the API key and as well as the URL, and then you need to define the vectors config and quantization config. So let's proceed with the code. You have the Qdrant client and then you have Qdrant client import models. So models is basically where your binary quantization class is written. So this is where we need this models. And this step is very important. We already have a directory. So if you see data is the directory, we need to load the data. And in order to load that, you have simple directory reader. And then we have from LlamaIndex.embeddings.FastEmbed import FastEmbed embedding. So this is where you need to convert your data into embedding format, and we will do this via batching. So what batching will do is you will send 50 documents at the same time and then create a batch of it. And then you will have LlamaIndex.llms.groq import Groq. This is for DeepSeek R1. So the first step is we need to load the source documents, and the source document is nothing but Bhagavad Gita PDF. And once this is done, probably let me check length of the data. So the length of the data should be equivalent to the number of pages that you have. So as you can see, you have around 890 pages. And now what we will do is we will check what kind of data is there within the particular variable. So I'll just run data and the 100th index. So here is where you will have metadata. So metadata is nothing but the ID you will have the file path, you will have the page numbers, when this file was created, and other details. And apart from that, you will also have the text data. Text data is nothing but what is the information in that particular page or in that particular chunk. So I'll just run .txt. Hopefully this should give me the data. So as you can see, you have the particular information that is within the document. Now what we need to do is we don't need metadata for this use case. Of course, you can use metadata and page content at same time, but in our use case, I'll just remove the metadata part. And what I'll do is I'll create a new variable called text, where I will loop through the entire data and I will just save the text data out of it. So now if I run this, and now if I click on tests 100, I will not have any metadata, rather I will only have the text content. That's it. Let me remove this. Now if I click on length of txt, it should be same as what you have in data. So as you can see, it is 892. Now it's time to use the DeepSeek LLM, and in order to use DeepSeek LLM, you need to use Groq APIs. And in order to create the Groq API, you just have to click on console.groq.com. You have to click on API keys, login, and get your keys. In my case, I've already saved all my API keys in the Colab secrets. So if you see here, you have Groq_API key. So what I will usually do is I will just use google.colab import user data, and from user data I will get my Groq API key. So in your case, what you need to do is instead of this particular part, you can remove this, you can directly add your key here. So you can replace this part with your existing key, and what I'll do is I will revert these changes and I will keep the user data where my key is already present. So in your case, you have to change this part. Make sure you do that. And now I'll just run this cell. The next step is you need to define LLM, and LLM is nothing but Groq, and the model name is DeepSeek R1 Distill Llama 70 billion. And I already showed you from where you can get this model name. And once you click on this, you can use a function called .complete. So .complete is where you can enter any prompt and you can get your result. For example, here I just asked a simple query which is hello, and if you see here, since DeepSeek is a reasoning based model, you need to think first and then generate the response. So in order to think, you need to have special tokens. So in this case, you have think and closing think, which is similar to HTML syntax. And if I give some other query, let's suppose if I give what is the meaning of life, probably it should give you some tokens within think. So if I run this cell now, so as you can see, you have think, and inside think you have few tokens which has been generated on what it needs to think before it can generate the response. If you expand this, you will somewhere find the closing think option. So let me search it. Let me search on think, and it should be closing brackets. Here is where the thinking is ending, and here you have the actual response. So as you can see, first you have the thinking capabilities and then you have the generated response. Now that we have defined the LLM, the next part is you need to have your embedding model, and for the embedding model we are using FastEmbed embeddings, and inside this you need to pass the model name, and the model name in our case is the NLP or GTE large. So you can take the model names from the supported models from this particular open source repo which is FastEmbed. And now As you can see, it is downloading the model weights. It is fetching 5 files where you have config.json, then you have ONIX format. So this is one of the functionality of FastEmbed, where it is converting your safe tensors or PyTorch files inside a ONIX format. And then you have tokenizers configuration, special tokens and tokenizers file. The next part is we will define the Qdrant client, and in order to define this Qdrant client, you have three different approaches. I've already explained what the three approaches are. I'll tell it again. The first approach is you can get the URL and API key, and in order to get this API keys, you have to click on cloud.qudrant.io. So if you are a new user, it will ask you to create a new cluster. So in my case, the cluster is already created. In your case, what you need to do is, it will ask you to create a new cluster. You have to give it a name, and then a cluster will be created. So you have to click on generate API key to get your API key. And for the URL, as you can see, this is the URL. You just have to scroll below. You will find the curl command, and there is where you have the URL. It starts with HTTPS and it ends with the port number. The port number is 6333, 6333. And now what we will do is, we'll look into the second approach. So the second approach is nothing but running in memory. That is nothing but your Colab. So this is the in memory part. You just have to define location and then colon memory colon. This is the second approach. The third approach is you can use the localhost. So localhost will be localhost /6333. You can check out the documentation. Usually this is how the localhost will be defined, but in our case we will not use localhost. Rather we'll be using the cloud itself, where you have the URL and as well as the API key. Just like Groq API key, I have already defined the user data.get, where I already have the Qdrant API key and as well as Qdrant URL. I'll just reuse my own API keys and I'll run this cell. Okay, I just have to comment this part. I didn't comment it out. And now what it will do is it will create the client, and we have already created the client. The next part is you need to configure the vectors config and then quantization config. And there is one more part, that is collection name. Whenever you have your data, you have to give a unique collection name. So this is very important, so that whenever you are creating a Streamlit app or your inference script of RAG pipeline, you just have to reuse this collection name to get your data. I don't want to change my collection name because it takes around 8 to 9 minutes to create this entire indexing process. I'll reuse the same vector DB that I've already created. Alright, it's time to create vectors configuration and quantization configuration. So here if you see this code, you have client.collection exist. I want to see if my collection name is already existing or not. If it is not existing, only then I have to create a collection. So now what we are doing, you define a client and now we are creating a collection where you need to define the vectors configuration. And inside vectors configuration, there are two things. One is your embedding size, which is 1024, and then you have the distance, where I'm using cosine similarity, and then on disk is true. And the last parameter is quantization config, where from models you need to get binary quantization and then define binary along with always RAM to be true. So this is how you define your collection if it is not already existing. In my case, the collection is already existing. So when I run this part, it says collection already exists. If collection is not existing, it will go through this process. I hope this is clear. Now what we will do is, we will convert our data into batches and then convert that into embeddings. So if you see this code, you have embed model. Embed model is nothing but your fast embeddings. Inside that you have a function called get text embedding batch. So here is where you have to pass your batch data, and in order to pass the batch data, your entire context, it's within this particular variable called text. And now what you will do is, you will loop through your batch size and you will take page to page. So initially it will be 0 to 50 and 50 to 100, 100 to 150, just like that. till 900 because we have the indexing till 890 pages, so it will go till 850 to 900. And then once you have the batches, you need to pass it inside the get text embedding batch and then save it in a variable called embeddings. So this will take around 8 to 10 minutes. This happens only once. You don't have to run this every single time. And once this particular process is done, this is where you need to save your document data and the embedding data inside update collection. So this is the next part. In Qdrant client, the first function that we used was to create a collection. Once you create a collection, the second step is update the collection. And in order to update the collection, you have to use the collection name again. Every single time whenever you are defining any collection syntax, you need to give this collection name, and along with that you have your vectors, which is nothing but your converted embeddings, and your payload is nothing but the context, which is your data. So as you can see from context in docs, so this docs is nothing but the batches that you have provided, and once you load this data, you just have to update your collection. So this is very simple process. You don't have to worry so much about it. This part will be executed within 30 seconds. Only converting your data into embeddings will take around 8 to 10 minutes, and creating the indexing, this part will take less than 30 seconds or less than 1 minute. And once this is done, here is where we will start with our retrieval pipeline. So here is where we will start with our retrieval augmented generation. So this is the second part of the code. So this part is already converted. Now what we have to do is we will start with search. So in search, the first part is you need to convert your user query into a query embeddings. So if you look at this parameter, you have a user query. So query is nothing but the user prompt, and once you have this user prompt, you have to use the embedding model. From embedding model, you have a function called get query embedding. Convert your user prompt into query embeddings, and once you have these embeddings, you have something called as query points. So if I open my slides, as you can see, you have query points. Inside this query points, you have to pass the collection name and the query embedding that you have converted your user prompt into query embeddings. And now you are passing the collection name and then query equals to query embeddings, the limit, how many relevant documents do you need, whether you need 5, 10, 15, you can define the limit, and then you just have to click on search. I will run this cell because I already have the collection name existing. And now what you will do is you will pass a user prompt. So here my prompt is, in Bhagavad Gita, who is the person devoted to? So there is a context regarding this person devoted. It's related to Lord Krishna. And now if I click on get relevant docs is nothing but the variable that was used. And then inside that you have a parameter called points. So let me show this. Relevant docs. If I run this, you have total 5 different elements. And inside this each element, you have a argument called points. So I'll use points for the 0th index. Sorry, it should be points, then here it should be 0. So as you can see, here is where you have your data. And you have the score of what is the relevant score. Here as you can see, it is 87%. And this is very important whenever you are building the RAG pipeline solution. And there you have the context as well. So this is how you are getting the search context directly from the relevant documents. And now once this is done, what I'll do is, from relevant documents, as you can see, you have dot points, then second index, and inside second index you have dot payload, and then you have the context. So you can observe it here. When you print 0, you have payload, inside payload you have context, and if I print the length of it, it should be 5. It should be 5. Now in order to get the search results, as you can see, it should be points, then the URL. So maximum it will go till 4. Why? Because limit is 5. 0, 1, 2, 3, 4. And then payload, get the context. So this is where you have your relevant data which has been passed from the LLM. Now if you come back to the cell, we have the user query done, we have the query embedding part done, we have the query points done. The next part is you need to define a prompt template. So in order to define the prompt template, there are two things. One is system prompt and one more is user prompt. System prompt is also very important. User prompt is where you define a template saying if the query is not from the context, then generate I don't know. So let's look at the prompt. So the next part is from LlamaIndex.core, import chat prompt template, chat message and message role. So there are two roles, one is system, one more is user. Message template equals to chat message. This is my system prompt. I want it to be an expert in ancient assistant who is well versed in Bhagavad Gita. And then you also need to give instructions saying that it understands different languages, that is English, Hindi and Sanskrit. So these are the instructions that you need to provide to your system prompt. So these are nothing but a role play instructions. And then you have a role is nothing but message role dot system, and then you have a user prompt. In user prompt you are defining, we have the provided context information below, which is your context str. Context str is nothing but whatever you have here, right? Your 5 relevant documents, combine all 5 of them inside a single variable that forms your context str, which is your context string. Given this information, please answer the question query. So if you look at context str and query, it is enclosed within a curly brackets. This is nothing but your input variables. And lastly, you have, if the question is not from the provided context, say I don't know, not enough information received. So these are the instructions that you have defined in the user prompt. So now what we have done, we have completed with two parts. Retrieval, augmentation. Retrieval is nothing but your search, augmentation is nothing but your prompt template. And the last part is generation, retrieval augmented generation. In generation, you will create a pipeline where you will pass your context as well as query, and then you will give it to the LLM. So if you look at this prompt, once you define the prompt, the next part is you need to give it to the LLM that will generate the response. So this is the last part. Now I'll just create a pipeline. So in this pipeline, I'll use the same variable, relevant documents. For the given user prompt, for the given user query, I need to search, get the data, which is relevant documents. And from this relevant documents, I have a ID, which is points. Inside that points, I already showed you there are payload. Inside payload, you have the context. Extract all the context and save it inside a variable called context. And second thing is you have augmentation, and you can directly use chat prompt template, which has two different chat message. One chat message is of message role system, one more chat message is of the message role user. And once you have the augmentation ready, here is where you are running the generate function. And if you see here, response equals to llm.complete. There are two input variables. The first input variable is context str. The second input variable is query. You just have to override these two using a function called format, and there you have your response. You just have to print your response. I will run this cell, and then you have a prompt saying, "Oh my teacher, behold the great army of the sons of Pandu, so expertly arranged by your intelligent discipline, the son of Draupad." Now what you need to do is you need to check what is the purport of it, and if you click on this, so this is the first user query that I am passing. Okay, I didn't run this cell, my bad. I'll rerun it. I didn't run chat prompt template, so it threw an error. I reran that particular cell. So now if you see, you have think, okay, so I need to figure out what is the purport of the given verse from the Bhagavad Gita, and then you have the verse, and then it is thinking what it needs to generate. And once it is done, you have the close think option, and then you have the final response. And just like that, you can ask other queries as well. Here I have one more verse, and then I'm asking it to explain the Gita's translation, and then again it will think, and then it will generate the execution. So here I have a shlok, and then it says, translates to, victory is to the sons of Pandu whose side Krishna is on. these statements, underscores, you have the response. So here is where we have built our Bhagavad Gita Assistant, where you are using Qdrant as your binary quantization, DeepSeek R1 as your LLM, and then you are creating a complete RAG pipeline using LlamaIndex framework. How cool is this? We'll go one step further. We'll build a Streamlit app for this. As you can see, I've already created the Streamlit code. I'll push this particular code to my GitHub so that you can utilize it and build your own application. So if you look at the Streamlit app, it's pretty similar to what you have seen earlier. So I'll break it down as well. So if you see here, you have to import LlamaIndex chat prompt template, LlamaIndex core LLMs, where you have to get the chat message for two different roles, system and user. And then you have the embeddings, fast embeddings, and then you have the LLM, that is your DeepSeek R1 from Groq. And there you have something called as cache resource. So this will run only once. That is, whenever you define your embedding model, this need not to run every single time. So this is where you have to use a cache resource so that whenever you run any prompt, it doesn't overload your entire Streamlit app. So this is very important to use Streamlit.cache resource. Inside you have to define your embedding model, LLM, and your user client. So these are the three constants that you are supposed to use in your application. And then if you see, the message template is same as what you had in your Colab notebook. So let me bring back the Colab notebook. So if you see here, I directly copy pasted the same message template here. You have the message template, then you have the search function. Search is also similar to what you have here. You have query embedding, and inside result you have query points, collection name, and query embeddings. Here also you have the same thing. You have the collection name, query embeddings, and then the limit. And the next step is you have the pipeline. So pipeline code is also already explained. Same code is added in the pipeline as well. You are using the retriever, you are augmenting it, and then you are using LLM complete. So let me close this. So as of now, the initialization step, the prompt step, the search step, and the pipeline is same what I already explained. The only extra step is whenever you're generating the response, right? If you look at the generated response, you have thinking along with your response. So when I'm creating an application, I need to add this thinking inside a expander so that I don't have to show it to the user. If they want to see it, they can click on expander. I'll show that feature. So if you see here, I asked a question saying, who is Lord referred in the data? It says the Lord referred to the provided context is Krishna, the supreme personality of Godhead. So this is the final response. If you want to see what is thinking response, which is within your think and closing thing, you can click on show thinking process. So this is your entire response. So in order to create this kind of UI, what you can do is you can extract the thinking from the response, where you have to find think and closing thing, and you have to extract that particular content. So once you extract this content, that's it. You just have to create your main function. In main function, you are defining this title. So if you look at this title, you have Bhagavad Gita Assistant. Let me bring back this cell here. So you have Bhagavad Gita Assistant, you have Bhagavad Gita Assistant, and then you have to initialize your embedding model, LLM, and client. This will run only once. This will run only once and be saved inside cache. Alright, and the next thing is you need to create a chatbot based interface. This is a constant template. You can get it from the documentation as well if you search for Streamlit chatbot. And the only thing what you need to change is whenever a message is passed, how are you supposed to display it? So as you can see, I need to generate the thinking and the answer. So whenever you have the thinking response, it should be closed inside the expander, and then you have to generate the markdown response, and else you just have to generate the content out of it. So this is a standard template. You can get it from the documentation as well. So let's run the Streamlit app. I'll ask one more question. What is the data about? And tell me about the role of Krishna, God. So now what it is doing, it is thinking, but it will only give you the response, and the entire thinking process will be closed inside the expander. So this is so fast. As you can see, it just took 1 second or 2 seconds to generate the response. So it's about Bhagavad Gita, especially focused on supremacy of Krishna as the supreme personality godhead. And then you have the role of the Krishna. Now if you click on show thinking process, this entire thing is happening in just few clicks of seconds, and this is the usage of Groq LLM. It's so fast, bloody hell. And now if you see, you have the thinking capability and you also have the response. You can ask the same prompt that I asked here, and I'm not using any GPU. I'm just running it locally on my Streamlit. If you see here, it's been running in my Streamlit run app.py. It's on my terminal, and as you can see, the response is being generated along with thinking process. I just love DeepSeek R1, and with Groq, it's great. It's so fast, and you just saw thinking and generating the response was happening at the same time. And this is it. I've already shared the source code on my GitHub. You can find all the links in the description. And we will be starting with the live session soon, where we will build more projects live so that you can build multiple cool projects and showcase in your resume. Don't forget to subscribe. We will bring more videos very soon. Thank you for watching.